the teacher of AIV, that stands for Accademia Italiana Videogiochi, Italian Video Game Academy. It's the oldest academy in Italy of this kind. It has 15 years. Today I would like to show you how we try to teach C++, modern C++, to future game developers. This is a list of the topics of the 3 years programming course. You have vector math, trigonometry, various graphics API, OpenGL, DirectX, and so on, scripting, machine learning, networking. They even cover Unix and POSIX stuff. And they even see a lot of different languages. They start with the C#, mainly for approaching Unity during the following months. The interesting stuff is that that before starting looking at C or C++, they do a lot of assembly with old architecture, 6502 and so on. They try to implement emulators. They program on emulators. They try to deploy their code on old console like PlayStation, Nintendo DS, and so on. From this year, they started even looking at Rust. Often, people, when checking our open days, ask us, why waiting 2 years for C++? C++ is the industry standard for game development. First of all, because we want to avoid the programmer approach at all costs. We don't want people too much self-confident in their programming skill. Because we want to give them discipline before tools. We want to force them to try to always use the best tool for the job. We don't want people that do not look at, I don't know, Python, Ruby, because they are too high level and so not too much for a macho guy. Be effective. So again, use the right tool for the job. And the most important reason is at the next slide. They have 2 years of time to be completely aware that humans sucks, has limits, and be totally addicted to testing, unit testing, functional testing, and so on, and good design practices. C or C++, they are strong weapon, and they don't want they shoot in their foot too early. How we approach the first lesson of C++ in the academy. As they did a lot of assembly and C, we start showing them what the compiler does with their code. Here you can see, this is C-lang for a Unix platform, the assembly you are seeing. Not too much different from the Windows 1. So the first slide they see is that, oh, the main function is the same in C and in C++. They even put out the same assembly code. And then they see name mangling. So something is quite strange for them because they are used to the C compiler using the same name of the function for the symbol name in the lower level stuff. So they realize that they have function overloading. So they have the same function with multiple kind of parameters, and they figure out how the name mangling works. So the 2i are the equivalent for 2 integers. And again, they see the assembly output. And we continue showing them how various functions, the same function with various kind of arguments, generates assembly code. And we spend a lot of time in the last one, because often in the high school, someone told them that using the little data type is better. No, absolutely not. You can see that code double when using a simpler kind of data. We show them how the constructor works. It has a cost because the heap allocation is a system call often. We show them the concept of plain old data. the whole kind of struct, and now it is initialized calling a C function, memset. And then we show them this kind of test, quiz, whatever you want, because most of them think that crash me, because it is a null pointer, can call methods. Maybe it's too little. Here, crash me is initialized to null pointer, and then they call a method. This doesn't crash, because hello doesn't call the instance, doesn't have access to the instance. And this kind of, students are not too trusting this kind of stuff, and they try by themselves to run in this code. And then we show them why it works, because generally every kind of methods became a standard C low-level function. If you do not reference the instance, you will have no problem. Why we go so low-level? Because you know nowadays we have a game engine like Unity and a real engine that make half of the stuff for them. But I can assure you that half of the AAA company are pretty tired of this kind of technician. They are specialized in a single platform. They have no idea what happens below the funny interface, graphical interface. Because optimization, and for this kind of software, game, optimization is really important stuff. You cannot optimize without taking measures, without having data. To get data from your code, you need the knowledge to understand what your code does. Another problem is that a lot of AAA companies, AAA is high-budget companies in the game industry, are strongly opinionated. You will see in the next slide the different school of thoughts. So students must be able to switch from a set of mind to another. Going solo level allow the students to understand how technology can make your life better. I've seen too much in my life people saying, I don't use an IDE because I'm a really strong guy, I can work only with Vim and compile from the command line. In the past, I was the kind of person that I understand the IDE can help you. This is a list of the school of thoughts in the AAA company. There are AAA companies that do not want modern C++. They want C with a bunch of classes. No references, no template, anything. No templates. The main explanation is because templates slow down compile times, and if your technician is busy looking at your code compiling, you're losing money. Absolutely no multiple inheritance. Honestly, I agree with that kind of sentence. Or the extreme case, absolutely no inheritance. This is, I think, a consequence of trying to avoid virtual every time. No exception. They compile their code without the exception support. A lot of companies do not want standard library. If you look at the Unreal Engine source code, you will find no reference to standard library. They have re-implemented basically everything you can think about, and this is a common approach in a AAA company. This is a bit foolish, no compiler optimization. In their mind, you need to write their code in a way that you do not need compiler optimization. This is completely foolish. If you expect to be better than a machine, you are in the wrong planet, I think. No preprocessor macros. That a lot of times become quite the opposite. Again, a real engine is a classic example of abuse of preprocessor macros. Basically, everything is in a define. Or check the Michele's talk later. Fully data-driven, so entity component system, avoid classic object-oriented, and so on. So how students can survive into this complex ecosystem? First of all, he needs to learn the various approaches. So he doesn't run away when during the interview, someone told him to not use templates or something like that. He needs to learn to adapt. It's the market that make the rules, not you. Learn to reduce the ego. There is always a better technician than you. Maybe the technology for which you spent years of your learning path is obsolete right now, so avoid the ego. And a lot of, more important, the idiomaticity of the language. If you are learning Python, use the Python style. If you are learning C, try to use some kind of C style. If you're learning Ruby, again, use the Ruby style. Don't try to match pattern you are used in C++ into Python and vice versa. So respect the idiomaticity of the language. The results of this approach are pretty good. We have 60% of students, of graduated students that find a good job in a gaming company. The other 20% go into the generic IT market. The other 20% became nothing, but I think it's something of expecting. Thanks for your attention. If you have questions, feel free to do it. Thank you.